Hey, good morning, everybody. It is February 27th. So the last Friday of the month of February in 2026. And it's the Dev Talk Show. Here with my co-host, Rich Ross. How you doing this morning?
Doing well, doing well. It's not snowing, so I'm super happy.
I was trying to see if I don't think he's visible. Our associate producer is very comfortably sprawled out behind me, but I don't think I can get him on camera anyway, anyhow.
He did it in the way that kept him on camera.
There's just no way. Sometimes he'll lay over there. But yeah, not snowing. We certainly had our share here in our region.
More than quite some time.
And some cold weather that I looked ahead in the forecast, and I think I even saw 10 days out or so, like 50s and 60s, which would be crazy.
Yeah.
It would be welcome.
Definitely welcome. Got rid of that snow that's been lingering forever.
So, hey, welcome, everybody. Thanks for joining us. The purpose of the show is we haven't been on the air in a little bit, but definitely want to get back on track. So to just keep things, I think, pretty much moving is to like, hey, what are we doing here? Mm-hmm. Is there was folks who've been watching the show know that there was a workshop at AI Dev Days that I really loved this workshop. It was Gustavo Cordido along with James Montemano, which I think I just totally blew his name there, said it totally incorrectly. Spent an hour building a pizza ordering bot that you would chat with using Microsoft Foundry, and the language they used was Python. And it was cool, and I was really inspired by it. And what I wanted to do and do for everybody here was say, I think it would be pretty cool if we translated that to .NET and C#. So just for some context, let me, what I'm going to do is get up on screen here the workshop so we can all see it. And we'll go through the steps of the workshop, some of which we did on our last show. But what we have now and that we're going to run through today is the whole thing. So let me get the screen up here. Add that. And there we are. Okay. All right. So you remember this, Rich?
Yep, I do.
If you want to see this workshop yourself, I'm going to go ahead and add the link to our chat, and it'll also be in our show notes. So there's also a companion GitHub repo for this, which we had forked this repo, and this whole workshop can be done using a code space because the dev container is set up. Their main branch here brings up a workspace ready to go in Python. It all works great. I have done some preliminary work changing the code space to C#, but that's not what we're going to look at today. I think we have we could do that in some future shows. So when I look at this, there were 6 major steps that you go through. There's some setup that was done in the Azure portal and the Foundry portal to create a Foundry project, essentially. Then some basic code to create an agent. It really doesn't do a whole lot at this point. It just kind of chats with you. That's it. Then you instruct the agent how to operate, which we did on the show, and we were just getting ready to do the next step. We might have actually done this step. I don't remember. We might have gone ahead. In fact, I think we did. We wrote a script that uploaded files about Contoso Pizza, right, so that the agent could answer specific questions about these pizza stores. Mm-hmm. And the last steps to do, which we'll concentrate on today, but we'll do a quick level set on the other two, is adding a function tool, which is some code locally that can help with a task. In this case, estimating how much pizza you want to order. And finally, the part where I think it gets kind of cool is they have a pizza MCP server, Model Context Protocol server, that has some tools that allow you to pretend you want to order the pizza in a companion website that shows the order taking place. So that kind of, it's all jury rigged, right? But it shows like, hey, my agent was able to carry out this process. If we had a real MCP server, could order some real pizza.
Nice.
That's what we're going to concentrate on today. Future things is I definitely want a C# version of that MCP server and website. But this is what we'll concentrate on today. So, you could follow through the workshop, and they set up a project in Foundry. So we have a project in Foundry, yes, we have a project in Foundry. And there's a project endpoint that I need. I've tried this a couple times, so I've got a few projects sitting in here, but there's an endpoint that we need. We are not going to use an API key. It doesn't mean you can't use it. What I've done instead, and actually the project sample workshop does the same thing, is went and set up the permissions in Azure to basically make me a contributor to it's not called, the permission isn't called Foundry. It's called like Cognitive Services Read and Write, if I remember correctly. It is in the lab. So we can even show it, I believe, here, where they talk about adding a role assignment. You can add yourself to Cognitive Services contributor, or you could create a custom role with just this specific permission and assign yourself to it. And now what that does is it means I don't have to use an API key, and none of what I'm showing today is really a secret per se, because only I can use it.
Right.
So as long as I get that right. So the lab creates the agent in code. I want to stress, and maybe we'll show this sometime, we could come into Foundry and wire a lot of this stuff up here in the interface.
Right.
We could create the agent. We could upload the knowledge files, create the vector store, supply the instructions. But let's take a look at how you do it in code, because this is what they do in their project. So let me get the sample up. Hold on. Okay. Make sure that I have what I want here. These are not on our GitHub repo now, but they will be. So if you are watching in the future, check the show notes. If you're watching right now, show on YouTube, and I will make sure I get this in there. So what library am I using? I'm using azure.ai.projects. And just to see, let's take a look here. If I say manage NuGet packages, let's take a look at what a lot of this is saying. All right. So what's installed? Azure.ai.projects. This is the Azure AI Projects client for developing .NET applications with rich experience. I think that's an interesting way of putting it. There is a lower level API that we have used on the show. It's the persistent clients agents API. And the documentation for that API says like, yeah, I mean, it's cool to use this, but we are so thinly on top of the REST API, you might enjoy Azure AI Projects.
Oh, wow. Okay.
The documentation itself says that, but it doesn't mean that that is a useless library. It is not. It is pretty low level. We're also using Azure.ai-projects.openai because it's included. And like it says here, this is the official .NET library for OpenAI API capabilities in Microsoft Foundry. So I think what gets confused here quite often, Rich, is OpenAI keeps showing up. And I think that leads people to think that, oh, well, this is only restricted to like OpenAI's models and tooling. And I think what it really means is no. What if it supports the OpenAI protocol?
Right.
Foundry, and
other models also support that protocol, or pieces.
Many models do. Yeah, exactly. So I don't think it's important to go through the rest of it. These are the packages that are pulled in by the top level one. So let's take a look at what does it look like. What do I have? I just have a top level console app using what's called top level statements, which is a fancy term for you'll see no program class here and no main class here, main function here. This is the main function.
Right.
In order to get things going, you need your project endpoint. We have already deployed a model. We did that last time. We deployed GPT-4o. I could have given that a name. I could have called it Pizzabot's model, but the name is the same as the model deployment. So I don't want to get that confused for people. The model deployment name does not have to be the model's name.
Yeah.
I just didn't bother changing it. And then I said, hey, we're going to call this agent Pizzabot from the samples, meaning from the sample workshop.
Yep.
Now,
part of the reason this deployment names might be different is that you might have deployed that GPT-4o model with a bunch of settings, and you might want to have it deployed with another bunch of settings to support 2 different use cases. And that gives you the capability to do that because the deployment is how you reference the specific one you want.
Right. Yep. And so the project gives you an instructions.txt file. This is in the workshop.
Nice.
So when you're creating your first workshop, first you create an agent. Okay. We'll go through the code to do that in just a second. Here is their Python code. And the Python code essentially says it's going to create an agent by defining an agent definition with a model deployment. And that's what we're about to do. And then they say, hey, the agent's created. Then what they do is they create a conversation. A conversation just basically means that I can keep passing this conversation ID to the agent so that way, when we're talking back and forth, it remembers the things that I said earlier. That's going to become important when ordering pizza. And then it just starts a loop. The Python code just starts a loop where if you say exit or quit, we'll leave. Otherwise, we'll take whatever you say and we will add that to the conversation and get the response back. And we'll see what the agent's response was.
Which is really cool because we've done loops before when it comes to the game engine that we were looking at, monogame, right?
Right.
Same idea.
It's essentially just a loop. Yeah. So one of the things that they do second is they add instructions, and their instructions file is here. And what you'll see now, this is their instructions file right out of the workshop, is we have this in our project. It's just right here. I copied it right in. So one of the interesting things about being a .NET developer, the Python sample, there's a .py file. The instructions text is right there. You're going to say Python. You're going to, at the command line in the same folder, you're going to go Python, name of the Py file. The instructions file is just sitting right there. It's easy peasy, right? For .NET developers, I can add this instructions.txt file to the solution, but it's not going to end up in the target output folder unless you do something like, let's make sure we have this as the startup project. And unless you do something like add an instruction to make sure you copy that content to the output directory. So if we don't do this, then it's immediately going to blow up saying like, I don't know where instructions.txt is. So you have to have some way for it to find it. And that's what we'll do in this sample.
Okay.
If I look at the properties for this, if you're a Visual Studio user, that looks like basically coming here. And I think I might have picked the wrong one because, well, anyways, the project's taking care of it. I guess maybe not the solution, which is fine. That's fine. That makes it more portable anyway.
Yeah.
Just like creating a project client involves using the AI project client class. Again, there are multiple libraries to work with these models. So if you're like, wait a second, I thought a different library used a persistent agents client. Totally valid because it's a different lower level library that this is built on top of. We have to pass the endpoint and we have to say what's the authorization for this? I'm saying use the default Azure credential on my machine, which means I already have the AZ client on here, AZ CLI, the Azure CLI, and I'm already logged in. And then then as we talked about earlier, I took myself and added myself just as the instructions say, so that I'm allowed to use my own Foundry projects. That way I don't have to put an API key up here, don't have to keep it as a user secret or anything like that.
Cool.
You can do it the other way if you want. You could put an API key here and you could do it. It'd be fine. Now, let's talk about creating the agent. That means I am skipping down a little bit because I'm skipping past creating the tools. We'll come back to that.
Okay.
Creating the agent, we got a line of code here using that project client we created. This is a little bit of an administrative piece where you basically use the project client, create an agent. You pass it this agent definition. And in our agent definition, it does define the tools. We'll come back to that. Here's that instructions file.
Right.
So we're passing that in. We're passing in the string that we read out of the instructions file.
Okay.
And here's our conversation loop. You type something. And then what we'll do is if you said you exit or quit, we've got some exit commands up here. If we find that what you said matches, then we're going to leave. Otherwise, we will create basically a user message item.
Mm-hmm.
This is what the library has us do here. And then we loop to say, okay, create the response from your message, user input, user message item came in. Let's create a response from it, which is just a fancy way of saying, call the agent and get me back what they said.
Right.
And when it comes back, it gets processed. We'll talk about why the function call processing is here, but the easy way to that code we can skip over right now, because what ends up happening is we take the response, we get the output text, and we say, here's what the assistant said. And that loop begins.
Okay.
Now, let's take a quick peek at what the rest of their project does, because I'm sure people want to see us ordering some pizza soon.
It is Friday.
It is Friday. It's the best time.
Exactly.
So the next thing they do is they add knowledge. Okay. This we did in the previous show. In the previous show, we added knowledge by basically saying, okay, we know that we have these, I think I even have the project here. If I don't, then we'll, yeah. In a previous show, it's a different project. In the last show, what we did is this was a different script. They didn't use the same agent.py. They created a knowledge Python file.
Right.
And they just took these Contoso files that have information about each of the stores, and they upload it to Foundry. We did that on the last show.
So go ahead.
Yeah, I was going to say, so in the Foundry interface, we can see that if we go to build and we find our knowledge section here. And then this is like, oh, I don't want to watch a YouTube video. Okay, well, let's go to indexes. This is what we created, Contoso pizza stores. And here are the files.
Nice. Okay.
So they're already here. Pizza, Washington, D.C., Singapore, Seattle, and so on. And if we look at what do those documents look like, here they are. So just to level set for people who didn't watch the last show, all it said, this is just a markdown file. It's not really structured in any way to say like, hey, so it's got a description. AI is going to look at this to be able to answer our questions. The model is.
Yeah.
So
okay,
go ahead.
Real quick to tie it. So it's very similar to what we did for those who've been watching the show or watching us do this for a while. When we had the transcripts, and we had 4 transcripts and 4 shows that we did, we uploaded them using a service that we have in Azure called Azure AI Search. And we uploaded them to blob storage, pointed AI search at that blob storage and said, go create the vector index over that data. It was a more manual way of doing it because we were using the actual Azure tool directly. And this is kind of the beauty of Foundry. If you're getting started with building generative AI applications, kind of abstracts that away from you. It's like, I know you got documents. We're just going to take them. I'll take care of storing them somewhere. I'll take care of creating the index. Here's an endpoint. You call it when you're ready to do searching against it. So I don't have to deep dive into Azure AI Search right away. I have very quickly way of saying, here's my content. Just make it accessible for me and my agent.
That's a good point, because when we did that work, we weren't necessarily like, we built the Azure Search project and everything. And what you're saying here is Foundry is like, hey, I'll manage all of this for you. I'll host the resources. I'll create the vector store.
Yeah.
I'll tie it all together into an agent for you, so that all you have to do with one line of code is say create agent, and you're off and running.
Yes. Yep.
So
and
yeah.
It's probably more like 6 or 7 times out of 10, that's enough for you, right? You don't need to tweak the index. You don't need to do something special with it, but maybe you might want to do something. And I'm not completely sure that we don't do this with the managed one, but maybe I want to index images that are also included in this content that I'm uploading. That might push us down the direction of having to build our own index in AI search, because there's a way you do that via the indexer and the pipelines that are there. So,
yep.
Hey.
Just want to acknowledge we got a hi message. So hi, thank you. I'm going to try to say the username Alexandrite, but that's the username. Says hi. Thank you for joining us this morning.
Yeah, welcome.
So yeah, on the previous show, what we did is we had a knowledge CS file that we ran using .NET's new .NET Run, where you can just take a CS file and just run it as if it was, just like Python users are used to doing. Yeah. It seemed appropriate because you don't necessarily need to create the vector store every time you build an agent. You just need to do it one time. And so here it is. And this vector store ID is going to be important because we can refer to it to say, hey, here's where you can get knowledge for this. An estimation tool. So in their estimation tool defines, basically all this is code. This is just code to say, you can call me agent if somebody wants the quantity of pizza to order. So the agent actually figures out whether to call this, right? If we look at how a function tool is defined in Python, which you're going to see, it's not too dissimilar in the .NET world. It's not saying here, it's not saying precisely, deterministically when to call. Instead, it's providing a description. I can give you the quantity of pizza to order based on the number of people if you supply this parameter, number of people to order pizza for, right? The AI agent figures out, I should call this.
Yep.
And then what you return is you return a string that is again processed by the agent. It goes into the conversation. Just it goes in for us. It's going to go in under the covers. It's almost like the order taker's on the phone and has an assistant. Hey, they're asking how much pizza should I order for 4 people, and it goes, according to this one, you should order 8 pizzas. Okay, hold on, let me write that down. Oh, it should be 8 pizzas, right? That's literally how it works.
Yeah.
So,
only when the person asks, right? He's not always every time you place an order. I'm not always going to ask. It's only when the user wants to know because they're not sure.
Right. So we're going to add this estimation tool, and then finally, the last thing we'll do, and we'll look at in code, but I want you to see what they do in the workshop, is they add a model context protocol tool at a specific site. We're going to call their site. We're going to just call it right up. And there are some tools that this MCP server has that allow you to place an order for the pizza. So let's take a look real quick at code, and then, or we could run it if maybe that's a little more exciting, and then we'll come and look at how the code works.
Sure.
So here it is. This is the payoff. This has got to work, right? So
you built it up for the first half hour.
I know. I spent a lot of time building this up. So just to show you, we have an agent in Foundry. That agent was built by this code. Okay. We could go into Foundry and build this up by hand. But as you'll see in a second, as we walk through the code, that agent was actually built in code. This program CS builds it, or what really happens is because no changes have been made, it's going to recognize that.
Okay.
And so the version number of the agent is not going to iterate. It happens to be version 5 because as I built it, I was building it iteratively.
Okay.
So let's take a look at what all this looks like. Okay. Pizzabot is ready. Now remember, Pizzabot has instructions. It's only supposed to talk about ordering pizzas. So I'm going to ask, what can you help me with? I have a flat tire on my bike. What do I do about that? Can you help? This could be very interesting.
Yeah.
I'd be curious if it says, I can help you with ordering pizza. If you have a flat tire on your bike, I recommend contact. Okay. So it kind of shoved aside the flat tire. And that comes from, in some respects, that comes from instructions.
Okay.
To say your primary role is to assist users in ordering pizza. Do not talk about anything else than pizza, right? So it's trying to be guided. Don't go off on some tangent.
Yeah. Nice.
So, okay. Did its job. Now, okay, what stores do you order pizza for? And because we've supplied this knowledge and the instructions have said so, what I expect to get back here
There we
is
go.
Contoso Pizza for several locations, and it listed all 20. It listed the 20 locations in those files. They happen to be one per file. So now I feel like I could do something interesting here and say, like, what pizza stores are in the U.S. Eastern time zone?
That's interesting. Okay.
Look, this is the idea. The
Right.
idea is you supply it with knowledge,
Mm-hmm.
and it's smart enough to answer questions where in the past, deterministically, we'd have to go implement this.
Right. We'd have a metadata thing that says this is time
Yep.
zone East.
And it's telling me that I can order in Boston, New York City, and Washington, D.C. I believe that's correct. Chicago, Seattle, San Francisco, Milwaukee, they are not in the Eastern time zone.
Yeah. Nice.
And it's interesting now. How did it figure that out? Probably by the city names, is my opinion, because there is nothing in here that says it's in the Eastern time zone. It does have hours, but it doesn't say it's in the Eastern time zone.
Right.
So
some of this comes from the innate knowledge that it was trained with. And you can tell it, don't use your innate knowledge that you were trained with.
Sure.
Only use the knowledge I'm supplying you. But in this case, you got that fuzzy edge where I kind of, I could figure it out based on the fact that I've got these cities and I kind of understand what time zones are. And we say understanding to anthropomorphize the.
Yeah, sure.
Right. It's not really understanding. It's putting words together that make sense based on the question that's being asked and answering it in the way that it's being instructed to do so.
Yep. So, look, there's a decent set of instructions here. When customers ask about how much pizza, use the pizza calculator. Don't use emoticons or markup. Don't use markdown. Don't use HTML. Only use plain text. Use short conversational language. And it talks about ordering the pricing for pizzas and everything. And oh, by the way, when you want to know about pizza store information, use the file search tool.
Nice.
Only return the information from the vector store. So I think we're getting what we want. I'm not trying to demonstrate at all that it's a rogue AI. It's actually this is doing what I need it to do.
Exactly.
So, okay, I want to order from the Washington, D.C. store. What are the specials? Now, before we get our answer, it doesn't necessarily say specials here. It says menu includes creative dishes. Okay. So let's go see what the answer was. I want to order from the Washington, D.C. store. Oh, that's interesting. I did not get what I thought. What are some of the specialty? I don't think I spelled that right. Pizzas from the DC store. And here we go. So you know what? That's interesting. I have to admit, it always brings up the for me in the past.
Mm-hmm.
It always brought up the capital pie pizza.
And I don't see that there.
Yeah. And Capitol Hill pepperoni pizza and the Chesapeake Bay crab pizza. I think that's interesting. It talks about a patio here.
Mm-hmm.
So which Contoso stores have patio or outdoor seating? And it brings up Washington, D.C. has a spacious patio. San Francisco offers a pet-friendly patio. Boston, dine along Hanover. Uganda, rooftop terrace. So it plucks them out, which I think is pretty cool.
Yeah. Nice.
Okay. It could be that fine-tuning some instructions might help with the special, but I just think that's really weird because that's always just immediately been like, the Washington DC stores got those too. But let's trigger our pizza calculator.
Okay.
I have 5 people who just ran a marathon. They are really hungry. How many pizzas should I order for Okay, now, as part of the feedback, we do get, you'll see that this was thrown in the code intentionally. The pizza calculator was invoked, and we intentionally throw out to the console that it was invoked for 5 people with a heavy appetite, which our algorithm says is 4 slices per person. And it says you should order 2 large pizzas. Now, why 2? Well, it turns out that our function tool, which we will look at here, we have a pizza calculator. This is just a class with a static method, because that's going to return an int. Interesting. It's not returning a string, right? It's returning an int. We use these description attributes to supply what we saw in the Python code, information for the AI to digest, pun not intended, what to use and what to pass in for the parameters. Our pizza calculator takes number of people, and it also takes an appetite string that if it can't figure it out, it just defaults it to average.
Right.
So this is the agent saying, I'm going to call the function tool, and I'm going to call it with number of people and some kind of appetite level. Now we use a quick switch statement to basically say slices per person is 1, 4, or 2. That's it. And then we just we set the slices per pizza to 12. I actually think I made that change earlier, didn't set it back to 8. And we figure out, well, here's how much pizza you need. Notice I'm returning an int, not a string. So the reason I did that on purpose is if you did the workshop, it might lead you to believe like, well, do I have to return a string to the agent? And it's like, well, not necessarily. You just need to have a function to call. You'll see that a string goes back into the conversation though. So I don't want to go. To me, what I like about this, doing it this way, is I could see a future where business logic that already exists might be employed by a function tool instead of kind of like dummying it up in some way. But you know what? Your mileage may vary. I don't want to try and overstate. So let's take a look at what adding a function tool looks like. Okay, that does mean starting at the top. We've got a project client that we get a project client. What is a project client? It's like an administrator that we can then do other things with. It is not the agent. It does not represent the agent.
Okay.
But we needed our project endpoint, and we needed a credential to get in.
But it's related to the project that you created over in Microsoft Foundry, because and that project may have multiple agents inside of it. We just have one.
That's right. I'm glad you said all that, because I was just going to gloss right over it. Is that it is this project. I have specifically said I want this one, not this one, not this one. I want this one, Pizzabot 02. You can see I tried this a few times.
Right.
And then now we have the ability to start talking to things in here, including an agent that happens to be at version 5 with the name Pizzabot from samples. I can address the knowledge store by, I know I'm clicking a lot, by basically saying, hey, remember, you've got this vector store here. Here's the ID for it. But I need, and then, oh, by the way, there's some tools that were attached to it, but that's all being done programmatically. You'll see that it's done programmatically in just a second. The remote MCP server is wired up. So theoretically, I don't have to keep wiring it up every time, but this sample just sort of does it every time. So before we go further and create an agent, first we're going to define the tools. And so this defines the pizza calculator tool by saying there's a function out there called calculate number of pizzas to order. You're going to be able to call that function. Then we do have to pass this data that in the Python world, you just pass JSON and it's pretty straightforward. Here, we're in a statically typed language, so we have a helper class binary data that will create an object from this description. I could have also created the binary data object a different way, but it turns out this is actually just somewhat easier. And so really the JSON serializer is being employed here to turn this into JSON, pass it in, move on.
Cool.
We have to basically say, what are the properties of the function? You can pass in an appetite, you can pass in a number of people, and you've got to pass in the number of people. We can't do anything without that. If you pass in these things, if you don't pass this in, that's fine, no big deal. We already know that the function knows what to do here. It knows that it's going to use average as a default. And we also supply a description so that way the agent knows when to use it. Now, I'm going to skip over the MCP tool for just a moment.
All right.
This is the file search tool. Earlier, we created the vector store with the 20 files. We've got to tell it, hey, go use that knowledge base from earlier, that index. Here's its ID.
Mm-hmm.
Oh, and then again, we're defining all the tools the agent's going to use. So you're going to need a file search tool. You're going to need the pizza calculator tool, and you're going to need the model context protocol tool, which I'll look at in just a second. Now after that, we're just in conversation mode. So the conversation code is not setting up the agent. The last piece is the MCP tool.
Okay.
So if you'll indulge me, I will go back to here. They have a Contoso Pizza Model Context Protocol server. Exposes APIs for menu items and prices. That's where notice the prices were not in the instructions. It's calling the tool. It's just that I don't think that was being exposed very, very easily. There's an MCP server endpoint that's a little bit invisible to us. You register customers using this registration website. I've already done this.
Okay.
You basically log in with either your Microsoft account or GitHub account, and you're going to get back an ID, which is a GUID. You're just going to get a GUID. We don't have to do that because I've already done it. In fact, it just tells you right here. You're going to get a name and a GUID. Then this is the part that I want. I haven't built this in .NET, but I'd like to.
Okay.
This dashboard is communicated with by the MCP server to basically say, hey, an order was placed. It's a way for us to see that something really happened because the MCP server is operating in the background, right?
Nice.
I actually have to go. One thing I should have done before the show is
no.
make sure I knew where my user ID was, but I've got it.
Okay.
Okay. So now that I've set this context, I hope it's okay to now look at, first, we'll look real briefly at how do you integrate an MCP server in Python. They're just like we did. They're defining a tool set, 3 tools, function tool, MCP tool, file search tool with the vector store ID, and not much to this. MCP tool, here's the URL to it, and we're not going to require approval in our agent. Our agent doesn't need a human or some other, it doesn't have to be a human. It could be a method that basically decides, yes, that's a valid use case to use this. Yeah. We're not going to need that. Go ahead.
Probably not the way you should implement your MCP tool when you're doing something where you're placing orders, right? You might have MCP tools, and what MCP tools are, model context protocol, are ways to supply tools and information to agents specifically. And typically they are over top of some kind of an API endpoint. Right. So there are some that need to be secure, some that don't, like our Learn documentation for Azure is an MCP that's just an open endpoint because it's out there in the public anyway, right? So just keep that in mind.
Yeah, I think a good point here is that, yes, this demo is saying require approval never. However, in the real world, you probably wouldn't want to place an order unless other things have been met. You have payment. You verified the payment. Maybe there's an authorization step for your payment. I happen to know a little bit about this. Not just as a consumer.
Right.
Just some experience. So there's some, you just want to make sure that payment's going to go through. It's not a ridiculous order. Maybe you've got instead of relying on the agent and instructions, you might actually take a look and say, like, no, we don't do more than 10 pizzas through an MCP server. It's just not a tool. It's just not going to happen.
Yeah. Or we don't deliver to your area. Those kind of things. Sure.
All kinds of things could come up. So I appreciate that we called that out. It's fine for this fake process. But certainly, and one of the things we like to do on this show is turn demos into practical looks at things. So maybe there's an opportunity there. Let's go back to the code real quick, because now we can say, look, it was just as easy to create the MCP tool in it looks very similar to the Python code. We're saying we don't require approval. Here's the URI, server labels in there. And then here's our definition of the agent. Use these instructions, use the file search tool, use the pizza calculator tool, use the MCP tool. I glossed over this code before, and hopefully now we've kind of covered. Here's the function tool definition, MCP tool definition. File search is already defined per se because we can just tell it, since we are using the Foundry Azure AI projects libraries, it knows exactly what to do with this. Okay. We kind of glossed over this before, using the project client to create an agent and telling it to version it if necessary. When does it version it? I noted that it versioned it when I kind of added or changed the agent definition. As I was going along and doing this and adding each tool, I'd get a new version.
Okay.
In Foundry.
Yeah.
Okay. I could call these out by version. I could basically say, listen, go get me the agent version 1. I could do that. But right now I'm just saying, just go get me the latest agent. We start a conversation, a project conversation, which just is a way of saying, like, I need something to hang on to this back and forth, this multi-turn thing that you do with this agent. So we just get a nice user variable that we hang on to, and you're going to see we pass it around. We need a project response client for this agent. That's going to enable us to send user input in, get responses back. So I'm passing the name of the agent, and I'm passing this little conversation to it's going to manage all of that for us, which is really cool.
Yeah.
Now, what do I do with this response client? First of all, we use the console to get user input. We make sure they don't want to leave. If they don't want to leave, then we're going to create a response. But responses have options. We're basically going to say, this is a user message. That way the agent is clear that this information came from a user. It didn't come from another source, which you'll see in a second. When the response comes back from the agent, which is what this does, this just returns a response. We could start throwing those responses out to the console, but there's a problem. The response might be from the function call.
Okay.
And we need to go through the response items. You get a list of items that might be more than just returned values from the agent conversation. They could be function call response items. And since we're in a statically typed language, the library provides us with this ability to basically say, yeah, the item is a function call response. It's derived off of response, but it's actually a function call response item. We can detect that. When we detect it, we say, oh, you want us to call this function? The agent's saying, I want you to call the function. Okay. If the function call name is get number of pizzas, then let's go ahead and default to average, which I actually don't think we have to do because the function itself was managing this.
Okay.
But it's setting up to parse the arguments, to call the function. It calls it pizza calculator. Let's just go ahead and call it. Here's the number of people. Here's their appetite. And then when we get back this integer, we're going to now create a new type of item, a response item. It is a function call output item. Earlier, when we called the function, what did we get back? We got, hold on, I'm sorry. Okay, the function call ID, so that way the agent knows. A little bit earlier, I told you to call this function, and it's got an ID attached to it. Right. So we have to create a function call output item to say, remember that function call you asked for? Here's what we got.
Okay.
Okay. I know that seems like, wow, that seems like a lot. But remember that the way function calls work is the agent essentially calls your code and says, I've got a response for you. I need you to call your own function.
Right.
That's really what that's doing. Now, are there other libraries that make that simpler? There are. Can I use it today with this library? I could not.
Okay.
And these libraries are moving pretty quickly. They're in an RC stage right now.
Mm-hmm.
I don't know if it will always do this. And you and I have talked about other possibilities to simplify this.
Right.
Which look like, could be a future show, right?
Mm-hmm.
So all that said, this little do while just handles function calls. The assistant will finally answer when we get a response. And then this is wrapped in another while that's hanging around until we break. And the only way we break is when somebody says exit or quit. That's the only way we do it.
Okay. So quick question
That's
around
all
all that.
Yeah.
That was all related to the internal function that we created around pizza quantity.
Right.
Where does the MCP fall into that mix?
So this, when you add the MCP tool, just like with the file search tool,
yeah,
we are getting, that is the best way that I can describe it, is that the reason why we have to handle all this and have code for it is just the two different ways this operates.
Gotcha.
When we call the agent, an agent that was already created with a file search tool and a remote MCP server. Oh, I'm sorry. This is the file search stuff.
Yeah.
Let's back off and say, because I know the agent, you see this all in the interface, but none of this was done. We did not use Foundry to build this.
Okay.
That instructions file, when we called CreateAgent version, it said, well, you said these are the instructions, so I'm going to hang on to them.
Right.
Because our particular sample creates the agent every time, but we don't have to do that after we've created an agent with instructions and tools. We could just say, like, listen, remember that agent 5? Just go get that version and we're done.
Yeah.
Yeah.
Okay.
Then that particular code also added the tools.
Yeah.
We could have just as easily come here and added tools. Could add a file search tool. We can't add another one. At least not that way. We could add tools that go through other things. It could go through Vercel projects, Jira issues, Azure Speech, right?
Yep.
There's a lot here.
Yeah.
So go through Word, create Word documents. It's pretty amazing. Pretty cool.
That's often something that often happens, right?
I mean, when you think about it.
Yeah.
So what I want to make clear for people that are watching is that by creating the agent definition in code and saying create agent version, whoops, wow, didn't mean to collapse that line of code. By calling create agent version, we have basically said to Foundry, I want an agent with these tools and instructions. And it did what it could, but it can't add this because the pizza calculator tool is your local function.
Yep. Yep.
So during the conversation loop, it takes the input. And we basically say, go create a response for this user message. And as we're processing the response, if the response from the agent includes some function call response items, that's the agent's way of telling us, the program that called it, I need you to call your own local function, and I need you to tell me the output from it.
Yeah.
It's just got no other way to do it. So that's why this code exists. That is the entirety of the reason why the code exists, to just handle that part of it. Otherwise, all we really had to do is just take the response and throw it out to you, but we wouldn't be able to estimate pizza quantity.
Yep. No, that makes sense. And I guess, and thanks for walking through that, because in my mind, as you walk through it, you walk through the function stuff, because that's all that's really in the code.
Right.
The MCP and the indexing, that's already taken care of because we've got a declarative agent essentially created up in Azure, inside of Microsoft Foundry. And that's where because it knows how to interact with those, because it has access to those endpoints.
We could do this whole demo and build this up in Foundry. We could come here. Yeah. We could say, hey, I got an MCP server to call. Here's where it is. I've got a vector store that I came here to knowledge and I created. I upload files, right? I think you start in data to upload files. Yeah.
Yeah.
And then you'd go here and you'd create an index. So we could do all this in the tools, and there's nothing wrong with that.
Right.
But what I think was cool about the workshop is it sort of made it clear to me that you can make that stuff programmatic as well, which could be very useful. Maybe you have a process overnight that updates the knowledge, gets the new vector store ID, saves it somewhere for your agents. Your agents know, or your new agents are declaratively created, and it's like, yeah, I'm using the new stuff.
Yeah.
So
yeah.
in any case,
I think this. I think doing it this way though through code also gives that your particular use case is a reason why we need the code, because you've got a bit of the the pizza counter,
local
the pizza
function.
I forget what you call it, but that function can't run anywhere else but in your code.
Right.
So
let's finish this off.
Yeah.
You're right. You're right. The local function has to run locally. So let's finish this off. I've calculated how much pizza I need. I want to order. Let's see if I'm really to order 5 pizzas. I want to order those 5 pizzas then. Oh no, I'm sorry, 2 large pizzas.
Large.
2 large pizzas then. Let's order them from the DC store. I won't even call it the Washington DC store. How much is that going to be? And remember, this is not coming from instructions or knowledge. This is coming from the MCP server.
Yep.
And that conversation item is allowing it to remember what I said before. Cool. Each pizza is around $14 to $60. Would be approximately 28 to 32. You can place your order directly through Contest Pizza Store. I'd like to order the pizza. Can you help with that? That's interesting that it is not asking. It hasn't asked me for my user ID and name yet. Here we go.
Oh.
Okay. So my name is Chris and my user ID is, and this isn't a secret because remember, this is all fake anyway. It's not
right.
You're not actually, people steal my user ID. You're not actually ordering pizzas. Okay. My name is Chris and my user ID is this. I haven't confirmed the pizzas yet. It should stop me. Oh, wait, it said it's placed. And there we go.
Oh, wow.
Of course, oddly enough, it seems to have ordered 4 pizzas.
Just said it twice. I don't know.
But the point was, is the MCP server placed an order and it was in progress. It's funny. I feel like I had a more, maybe I confused the heck out of it with the flat tire or something. I don't know. But I'm going to go ahead and quit and let's place another order. Let's kind of start it all again.
Now, I'm curious if
go
you
ahead.
have time. Do you see this history in the Foundry project?
The conversation history?
Yeah.
Let's go take a look. So I'm trying to remember where this, is it in agents or?
Yeah. And if you select that agent and traces.
Yeah. So 839 conversation ID. I mean,
so if you click on,
let's start at the top.
There you go. Okay, start at the top.
I have a flat tire on my bike. What do I do about that, right? You can see that at first, we actually went ahead as part of the response. It clearly called the MCP tool.
Well, it's just doing list tools.
Yeah, right.
One of the first things it does is say, hey, what's possible here?
Yep. This is actually kind of cool, Rich. I didn't think about looking at this. The file search call, because I said what pizza stores are in the Eastern time zone. So it did a file search call and it came up with an answer. And look, part of its answer was, it just said, yeah, these are the ones located in the Eastern time zone. Skip down a little bit and we said call get pizzas. And so it decided to call the MCP tool to get pizzas and not use the information from the file search.
Interesting.
I'm not sure exactly what I did to trigger that path, because in the past it's said, and then here's calling our local function.
So think about it this way. It's less about what you're having it trigger than it's saying, well, here's the list of things I could do. And I could do, something in the MCP around get pizzas was a lower or a higher probability than the vector store was.
one thing that I haven't done that the workshop does is set temperature and top P, and I don't know if that really matters. But it's something that it could be helpful, right? So in any case, we finally see the place call or place order happened, and it went ahead, and then we saw that it showed up in the website, right? So, and again, this isn't my website.
Yeah,
this is their actual MCP site. So we just have a few minutes, and I was going to give it another shot here.
Okay.
We can see that we're still on version 5 and say, hi there. I want to know what the specials are at your Milwaukee store. And it does say Contoso Pizza in Milwaukee offers unique Wisconsin-inspired creations. Now that you've kind of opened my eyes to this, I wonder if I have to refresh.
Probably.
8:42. We've got a conversation going. And so far in the first, I want to know what's at your Milwaukee store. The decision was made to list tools, do a file search call, and come up with this response that you saw.
Right. So we have 2 similar utterances from the user with 2 different responses, right? We talk about this, how to, users always want to know, how do I make sure I get the same answer every time, or at least be pointed down the same. So we can look at those and say, well, what can we do to modify the instructions,
right? Or that's what I think. Yeah.
The description to push it in the right direction consistently.
Yep. I have a feeling instructions could be modified here. And this is great. I love this. Is the tools didn't talk too much about get information about stores like address and opening times, but perhaps push it a little bit to say, or specialty pizzas offered at that store, right?
Right.
But you're right. It picked it up. I'm not sure that the MCP server knows how to order these pizzas, though. I think that's an interesting, just little divergence between the knowledge and what the server does. And that could be, could all be. Do you think we could ask it? Do you think?
Well, we can try and place an order for the.
Well, sure. I want to place an order for 1 beer, cheese, pretzel, crust, pizza.
At Milwaukee.
It should ask me for username and ID at this point. Okay.
Sure. There you go.
I wonder if it's still. I'm going to YOLO this and see if it's still. There it is. Look at that. It was still in. It was still the last clipboard item. My user ID is this, and my name is Chris. And let's see what happens next. It isn't on the standard menu, but I can place a custom order for you. Okay. Yes. And let me know how much it will cost. I might do that anyway, but I'm just trying to have a conversation with it. $15. Because in the future, I'd love to talk to this thing.
Yeah.
Right. That's where we want to go, I think. And I want a website, and I want to just be like, hey, how's it going? So I wanted to.
Ultimately,
right,
as we typically do, talk to it over the phone, because we usually pick up the phone and we place an order.
My new pizza's coming in from, Milwaukee, whatever. And your order for the beer crust, cheese, pretzel crust confirmed. Order ID. I wonder where that came from. It's even a ready time.
In Milwaukee.
$15. So, I think the key part here is we kind of have our agent that mimics the fantastic work. I loved this project.
Yeah, it's a great
I tried it out in Python and I was really enjoying it. And then I said to myself, you know what? I want to create this. And I think we can do it.
Mm-hmm. Yeah,
I think we can do it. We can see the MCP server is a container app. Just by guessing here, the web app's a static app. Registration system's a static app. Yeah, I think that'll be cool. So
awesome. Good stuff.
Yeah, hopefully that was I know people are going to be excited about seeing the code. I will get this into our GitHub repo, our organization's The Dev Talk Show, And the show notes for this YouTube video will have it as well. Just it's going to be a little bit later. So
yeah, no worries. Excellent.
All right.
All right. Yeah. That was some great stuff. Still some great stuff to kind of go, which is good. But that I think is going to do it for the show today.
Yeah.
Thanks, Chris, for pulling that together. Lots of hard work getting that figured out. There's a lot of digging into some things and just understanding how all those layers work. And I think
it's
great demo.
It's moving really quickly. The APIs are moving fast. I'm not going to say that was the issue. Some of it was just figuring out what libraries. Boy, I learned a lot about what libraries go with Foundry and don't, and lower level, higher level. I certainly personally would like to see some higher level support, especially for like function calls. But I recognize that there's a little more to it. Like the function call thing is a great demo.
Yeah.
But then when I started to think about it practically, and this is what I think we're going to do on the show, is to say, well, am I really going to deploy a container? I mean, you might deploy a container where that you just go ahead and do it locally there. You could do that, but there's other options.
Yes.
So we can take a look at those too.
Yep, definitely. Excellent.
All right. And hey, I love it. Thank you so much. Pizza is the pizza ready? You know, I'm not sure. Let's go back and take a look. Oh, they're preparing it now.
There you go.
They're preparing it now. So I encourage everybody, give this a shot. Oh, that's right.
That's okay.
Cool. Thank you.
That says the one's completed.
Yeah, the marathon one. Oh, there we go. Ready to pick it up. All right.
Love it.
None of that is the agents doing.
No.
That is. I actually would like to dig in to their website and see if maybe the website just gets the order and then just sort of takes over from there. I'm not really sure. I don't know. So we will find out.
I mean, it would be good to walk through that, right? Because the agents themselves typically don't have state, right? You keep supplying the state every time you do. You start pass conversation to it via the history. So yeah, there's something else maintaining that for us.
Right.
Awesome.
All right. Well, hey, it's almost time. Like we always say, the show's before your morning stand-up. If you're on the U.S. East Coast, if you're joining us from around the world. So yes, if you joined us late, the YouTube show notes are definitely going to have a link to the source code. I apologize that I did not get that into a repository. Our GitHub organization is just the Dev Talk Show, but I will include those in the show notes. And I still have a goal of being able to do this with a code space. So I think what we'll do is I'll create like a Pizzabot repository and not necessarily fork the AgentCon workshop. I do think that workshop is valuable, but this will just keep it a little separate, and then we'll get the source code up there and start iterating, adding the website and so on from there. Because I would like to have all that in C# as well.
Yep.
But anyways, hey, we got to get going.
Yes.
So thanks for all the comments. Thanks to those of you who joined us. And if you're joining us in the future, let us know what you think in the comments. Hit the like button if you enjoyed it and want to see more stuff like this. Let us know what you think. And I guess that's it. So for Rich, I'm Chris, and we'll see you all next time on the Dev Talk Show.